Welcome back. We will conclude this module and the course with a discussion of open problems and challenges that SDN faces in the near future. Before we jump into the discussion of specific problems and challenges, I want to offer a brief caveat, which is that there are way too many problems that SDN is facing in the near future to discuss in a single short lecture. So instead of discussing all of them, what I've chosen to do is recap some of the highlights of problems that emerged from our discussion in the course interviews with many of the luminaries in the field. The list of problems that we'll go through in the lecture also reflects a bit of my own bias as far as what I think are some of the more interesting problems that SDN faces in the near future. When we think about open problem areas in software-defined networking, we can think about them in terms of three different areas. The first is open problems concerning the northbound API and applications written on top of this API. There are problems related to wide area networking and interdomain routing, as well as programming and debugging software-defined networking programs written using these APIs. As far as the control plane is concerned, we've talked about many open problems, including those related to security and data leak prevention, the idea that one could leverage the increasing amount of data about what's going on in the network as far as failures, traffic patterns, and so forth, to develop intelligent network management primitives and applications, and orchestration, or the ability of an SDN controller to coordinate the functions of an increasingly diverse set of network devices. We've also talked about open problem areas related to the data plane, and in particular, how we might move beyond the constraints of the current match action paradigm that OpenFlow offers. Let's now talk a little bit about each one of these open problem areas in a bit more detail. As far as developing new applications and services, we studied the use of software-defined networking in various contexts and for various applications. But it's important to remember that SDN is just a tool. It does not specify a particular application, and it does not by itself solve any problems. To take full advantage of SDN, we must still identify the compelling applications that ISPs and operators want and need that depend on SDN. It is only at that point that operators, ISPs, and others will start pressuring vendors to include various SDN features in their network devices. At that point, we may see a much more dramatic tipping point as far as SDN deployment is concerned. As far as wide area networking is concerned, we looked at interdomain routing and saw that it was quite brittle. The mechanisms today for controlling path selection are extremely indirect. Policies are only based on destination prefix instead of on a rich set of fields in the packet headers. And an ISP or autonomous system can only influence traffic flow for a direct neighboring AS, not how traffic flows along an entire end-to-end path or in a remote part of the network. We explored how deploying SDN at an internet exchange point might introduce disruptive change in interdomain routing. But in the future, it is incumbent on us to explore how the deployment of SDN at internet exchange points and other places in the wide area can enable new protocols, business models, and applications. For example, today's business relationships between ISPs are still extremely monolithic and coarse-grained. SDN allows the potential for ISPs to design and implement a much richer and much more flexible set of interconnection policies. It will be very exciting in the coming months and years to see whether ISPs take advantage of this increasing flexibility should software-defined networking be deployed on a much broader scale in the wide area. As far as programming and debugging is concerned, programming applications is getting easier with new high-level languages, as you both saw and experienced in the programming assignments for this course. Nevertheless, it is still difficult, and coupling and composing heterogeneous control programs is not always possible. For example, if one control module is written in POX and another is written in Floodlight, it is very difficult, if not impossible, to compose those different control programs. Debugging is also very challenging. We should be thinking about how to adapt programming models for SDN to make it easier to compose heterogeneous components for control, and also how to make debugging and testing much easier than it is today. As far as security is concerned, it's worth reiterating that the current Internet architecture has no accountability built in, and security properties are extremely difficult to verify and enforce. Data leaks are also incredibly common. In one of the interviews, we talked about the potential use of SDN in preventing data leaks. It might be interesting to think about whether something like a formal lattice-based security model could be translated into low-level flow table entries using an SDN framework. We have also seen how software-defined networking makes certain network management tasks easier. Yet no existing technology takes advantage of the huge amount of data that's being logged at a variety of devices throughout the network. We have so much information about regular traffic patterns, the potential ability to predict traffic surges, network component failures, and so forth. We really need ways of mining configuration, traffic demands, and other patterns that may exist in all this network data to enable more intelligent network management. With the combination of data mining and machine learning with software-defined networking, we might ultimately be able to design truly intelligent network controllers. We saw in recent modules that SDN is a lot more than just match action. It is a lot broader than the OpenFlow protocol. SDN describes any logically centralized control of multiple network devices. We've seen several extensions to the match action paradigm, including the OpenFlow chip and orchestration of middle boxes and programmable custom packet processors. But we still need a unifying control framework that allows us to coordinate the increasingly diverse set of network devices. In summary, there are many open problems in SDN in many areas, ranging from the northbound API to the control plane to the data plane. Using what you've learned in this course as a starting point, you are now very well equipped to solve the next set of problems that SDN faces. I hope that what you've learned in this course proves to be useful for you in thinking about this next set of very interesting problems in this very exciting time for software-defined networking. Finally, I want to thank you for taking the course. It has been an absolute pleasure for me to teach you in this course. I've learned a lot both about software-defined networking and about how to teach a massive online open course, and I hope to see you again in my future course offerings, both on software-defined networking and on computer networking topics in general. If you're interested in pursuing any of the open problems that we discussed as research problems, I strongly encourage you to contact me personally by email. I look forward to seeing you and hearing from you in the future, and thanks again for taking the class.